Hi everybody. It was nice to talk to you last Thursday. I'm recording this video with my colleagues Eleni, Jessica, and Ryan. Say hello, everyone.
Hi.
Hello.
Hello.
And we want to give you some information on the waste sector to talk about the ways in which we can include emissions from waste incineration, of municipal solid waste, and of medical waste in LEAP. So I want to give a tutorial for those sectors, how we can create the structure in LEAP, but also how we can then enter the data from the report. And Eleni, Ryan, and Jessica have been through the reports and have particular questions about those sectors. So let's get started. I think the first thing that we want to do is to develop this waste module in a new LEAP dataset. And we can then combine it together with what we're doing with for the residential sector, what we're doing for the other sectors, and the data set from Dr. Sothia at the end once we have everything ready. The reason for developing it in a new LEAP dataset is that it's much easier to create new branches, to create new variables, and to put it all together and then to combine it at the end. So the first thing that I'm going to do is to click New, and we're going to call this Cambodia Waste Model. So I'm just going to call it Cambodia Waste Model, and then I'm going to click OK. And then I am going to go to the settings screen. It says we suggest you review the settings for this area. Do you want to review the settings? Yes. So I have non-energy sector effects switched on, which I need to have switched on to be able to look at the waste sector. The only thing that I'm going to change here is I'm going to increase the first scenario year to 2018, I think. Eleni, Jessica, or Ryan, do you remember what year the data in the waste report is from, or does it not say?
So for the agricultural crop burning, I think it's from 2015.
Okay. So we want to make sure that we cover the years that our data is from, and we need to have a balance between all the sectors, between what is in our current accounts, in our historical emission inventory, and what is in the projections out to 2030. So we can very easily change this in the future, and we can make sure that it is harmonized across all sectors. At the moment, I'm going to set it at 2018, my end year to 2030. Then I'm going to click Close. So I'm going to be working in the non-energy sector. I'm going to be working there because the waste sector is in is a non-energy sector. The first thing that I want to do is right-click and click Add. And I want to create a new category called Waste. Now, there are lots of different emission sources in the waste sector. Some are more relevant for air pollution analysis, some are more relevant for greenhouse gas mitigation. We're just going to focus on the waste burning ones. We could add in methane emission from landfill sites, which is important for greenhouse gas mitigation. We could add in wastewater emissions, so we can build on this data set. But I think it's important to do the key sources first before we then go ahead and try and look at all the different sources. So in the waste sector, we then want to add, and we want to include a new category called municipal solid waste. Eleni, Jessica, and I have been discussing, and in the waste burning report, we could create all 25 provinces separately in this waste analysis. So we could have each province and the emissions from each province calculated separately. We think that might be a little bit too much and take a little bit too much time, but that's completely up to you. What we want to do in this video is show you how we can do that, how we can create separate branches for the different different regions. So what we're going to do is look at the waste sector in Phnom Penh and then in the rest of Cambodia. But you could split it into other provinces as well if you wanted to. So I'm going to right click and then click add, and I'm first going to create a branch called Phnom Penh. We have two places where our waste could be burned according to this report. We have waste collection. So we have waste that is collected, but from these photos, and I'm sure you're aware, we can see that waste is burned at these landfill sites. So we have a source here where waste can be burned. We also have uncontrolled waste, waste that is not collected, and that can also be burned. So we want to have two places where waste can be burned in LEAP. So I'm going to click add, and then I'm going to call it landfill. I could call it dump sites or unmanaged landfill sites, whatever is most useful. And then I'm going to add one called uncollected. Then I'm going to click OK. Then I want to add the pollutant that is the pollutants that are emitted from this from Phnom Penh from the burning of waste. And I've actually made a mistake here. I'm going to add in landfill and add in uncollected from another LEAP dataset so that I can automatically import the emissions of all the different pollutants into this dataset. So I'm going to right click and I'm going to delete landfill and delete uncollected. And if you're cleverer than me, you wouldn't add them in the first place. So to insert these branches, I'm going to click insert branches from other area, and I'm going to go to the ASEANA dataset. And I don't want to import variables like scenarios or user variables or effects or units or tags. I'm going to click do not import all of those. So I click insert branches from other area. Do not import, and I need to select the right ASEANA dataset, this one here. So let me select the dataset, Dr. Sothia's dataset, because that dataset also has the emission factors for waste burning. So I'm going to use Dr. Sothia's dataset. But I could also use the ASEANA dataset if it works on your laptop. So here in Dr. Sothia's dataset, we have all of these emission factors for different pollutants under this branch called Urban SWB. So I'm going to click OK. I'm going to say I want to insert that branch under Phnom Penh. If I insert it under Phnom Penh, I have then my 10 pollutants that are being emitted from landfill sites or from uncollected waste. Now that I have landfill here, I can copy it and paste it under Phnom Penh to get another copy of this variable. And I'm going to call that uncollected. So now I have my two sources of waste being burned in Phnom Penh. Waste from landfill sites and waste that is not collected and is burned in homes. The next thing I need to do is to put in the methodology for how we estimate the emissions from landfill sites. So the first thing that we need to do to be able to estimate the emissions is to understand how much waste is generated. And we have that information here. We have the waste generation rate in Phnom Penh. We have the waste generation rate in Phnom Penh, and we have the percentage of waste that is collected, that is recycled, and that is uncontrolled. So to be able to enter the waste generation rate, to be able to input that into Leap, we need to create something called a user variable. So user variables can be anything. They allow us to create new variables in our data set that we can use in our equations, that we can use in our emission methodologies. And we can create them by right-clicking up here and clicking Adding User Variable. So I'm going to call this user variable Waste Generation Rate. And I'm going to use the units kilograms per person per year. And then in the notes I can give a fuller description of what this variable is. Annual generation of municipal solid waste. Then the key thing that I need to define is the visibility of this branch. The visibility of branches tells us where we can enter data for this variable. So the first thing that I need to say is, which scenario do I want it to be visible in? If I check current accounts, I can enter this user variable for I can enter this user variable for my historical period. If I check scenarios, I can look at how it changes into the future. So I want to do both for waste generation rate. Then down here, I need to select what type of branch I want this to be visible at. Well, I want to define the waste generation rate for Phnom Penh and for the rest of Cambodia, which I will create in a minute. So I want it to be visible at one of these yellow category branches. So I want it to be visible non-energy sector categories. I want it to be visible at the level of Phnom Penh and at the level of the rest of Cambodia, which I'm going to create. So the top branch where I want to be able to enter this data is called Municipal Solid Waste. So that's the first place that I want to be able to enter it. I don't want to be able to see it at Municipal Solid Waste. I want it to be able to see it one level down, which is at the level of Phnom Penh. So let's see what happens when I click on Phnom Penh now. I have this new variable, waste generation rate, kilograms per person per year. So then I can enter that data. The waste generation rate for Phnom Penh is 1 kilogram per person per day. So I need to make that adjustment. 1 times 365. And then I'm going to enter a note. So, or I can enter a reference. So, open burning report. So it's clear where that information is coming from. It's coming from the UNIDO open burning report. So I can enter that there as a footnote by putting a question mark and then writing the rest of my data in here. Okay, I want to then add in, so in the other LEAP model we already have population added in here. So I want to add a key assumption here called population. And the units are people. So let me just, as a default dummy value, put in 15 million people as the approximate population of Cambodia. I'm just putting this value in here as a placeholder. When we combine the data sets together, we will use the actual population values that are in the overall LEAP data set. So this is really just a placeholder. But we need that value to be able to calculate the total waste generated. And I want to calculate that variable, in another user variable. I'm going to create another variable, total waste generated. And I've made another mistake. It has gone red because it says total is a reserved function name. It means we can't use the word total because LEAP has attached a meaning to it. So I'm going to just do an underscore so that it's still clear what it means. Total waste generated. And the units I'm going to put are tons. Total waste generated in each region. This is my note just to explain it a bit more fully. Now I need to go to my visibility. Current accounts and scenarios are correct. Non-energy sector category. And again, I want this to view it at Phnom Penh and other regions in Cambodia. So now I have total waste generated. And this time I'm not going to enter a value in this variable like I have here. I'm going to enter an equation. The total waste generated in Phnom Penh is equal to the population, which is stored here, multiplied by the population in Phnom Penh, which I have already calculated, 18% of the population. So 18% of the population live in Phnom Penh, multiplied by the waste generation rate. Now I need to be really careful here. This value is in kilograms per person per year. And I've said that my unit of my total waste generated is in tons. So I need to do a couple of things. Here, key population is in units of millions of people, but the waste generation rate is kilogram per person per year. So I need to delete the million so that it's just in people. You might have seen the graph change. Now we've got millions of tons. I then need to divide it by 1,000 to convert my kilograms into tons. So we can now see that the total amount of waste generated is almost 1 million tons, which is very close to this value here. If I'd have used the actual population, I would have got it exactly correct. So I've got my total amount of waste generated. Now I need to know how much waste is of different types of waste. How much waste is organic waste? How much waste is metal and glass and of different types? Because, as is described in Dr. Sothia's report, the amount of waste that can be burned, we need to subtract the metal and the glass, which can be assumed not to be combusted. So we need to take off the metals and take off the glass. So I'm going to then add another user variable here called fraction combustible, and that is a fraction of waste that can be combusted, i.e. organic, paper, plastic, not including metal and glass. So we can then subtract the waste that is that we can then take into account the waste that can't be combusted. And here I want to define this at the level of landfill and uncollected, because it may be that more waste is taken to landfill of one type than another. So I'm going to define this at the level of municipal solid waste and select non-energy sector categories, but I'm going to say I want to define it 2 levels down. So look at what happens here. Now we can enter a value for landfill and a value for uncollected. Now at the moment, the data that we have is just from Dr. Sothia's report. And he says that about 5% of the waste is metal and glass, which were not considered combustible. So we're going to put in 0.05 for both landfill and uncollected, because we don't have any further information about these values. So we've now got our waste generation rate, our total waste generated, and how much waste is combustible. We've got one more variable, I think, maybe 2 more variables before we can then estimate our emissions from municipal solid waste. The next variable we need to add is fraction waste disposed. And that is a fraction. We could also make these as percentages. So this is the fraction of waste disposed in each waste stream. So this is how much waste goes to landfill, how much waste is uncollected. So this is again a non-energy sector category. And then we want to define it at the level of municipal solid waste and be able to see it 2 levels down. So we can say how much waste goes to landfill, how much waste is not collected. And then I'm going to add a final variable, fraction recycled. So that is a fraction. The visibility is the same as the previous values. So municipal solid waste and actually 1 level down. So I just want to be able to enter this for Phnom Penh. The fraction of waste recycled at Phnom Penh is 5%, so 0.05. And I'm using this to then calculate the amount of waste that is disposed in each of these waste streams. So let's have a look for Phnom Penh. 83.33% of the waste is collected, but 5% of that goes to be recycled. That means that 78% of the waste goes to landfill sites. So I'm going to put in here fraction of waste disposed, 0.8333 minus Phnom Penh. Okay, so I'm having trouble entering this variable. Let me show you another way of doing it. So for landfill, I want it to be 0.8333 minus this variable here, fraction recycled. What I can do is click on Phnom Penh, drag it into this box, and then I get the variable in the correct format that I hadn't remembered. And then I can click submit and I have it entered there, no problem. So then if I look at the table, I can see, if I increase the decimals, that I have 78% of the waste going to landfills. And then the uncollected fraction, I could enter that directly as 17%. But there's a better way of doing it. I can enter it as in an equation, which should be 1 minus landfill waste disposed minus fraction recycled. That makes sure that all my waste will go somewhere. All of my waste will end up either in a landfill site, either not collected or recycled. So now I have all my waste going to the correct place. I've thought of one final variable that we need to enter, maybe two final variables that we need to enter to be able to characterize the amount of waste that is burned. This one here is called the fraction burned, and that's a fraction. Fraction of waste openly burned. This is a non-energy sector category. I want it to be visible for all municipal solid waste branches. And I want it 2 levels down because I might have a different amount of waste burned at landfills compared to uncollected. At the moment, I'm going to put 0.6 as IPCC 2006 default. And I'm going to do the same for uncollected. Okay, so I think we've got all of our variables to know how much waste is actually burned. So let's enter that value. Let's calculate that value. Add user variable, total, and I have to do an underscore, waste burned. Tons. Total mass of waste openly burned. And this has the same visibility as our previous branches. And we are 2 levels down. Got total waste burned. And this we're not entering a value for. We're going to calculate it from all of the variables that we've just entered into Leap. And to be safe, I'm going to do this in the builder so I don't make the mistakes that I made previously. So I already have my total waste generated here. So for landfill, it is my total waste generated. So let's get that variable in. Total waste generated multiplied by the fraction of waste that is combustible. Total waste generated times by fraction of waste that is combustible. So that gives me the total amount of waste that can possibly be burned. But then I need to know what fraction of waste is disposed in landfill sites. How much of the waste actually goes to landfill sites? And that's takes into account the amount that's recycled already. So I don't need to recycle that variable, if you'll pardon the joke. The final variable that I need to enter is the fraction of waste that is then burned. And that is then my total expression for estimating the amount of waste that is burned in tons. And I already have my total waste generated in tons, so I don't need to worry about the units. I have exactly the same expression for uncollected. I just need to press Ctrl D, and it will copy it down. And the fraction combustible, the fraction of waste disposed, the fraction of waste burned will all be the same. Okay. The final thing that I now need to do is to calculate my non-energy effect loading. My non-energy effect loading is what are my emissions of different pollutants from burning this waste. So at the moment we have a strange expression in here. We're going to delete that. And what we want to enter here is now a equation to calculate the emissions. So I could enter another variable here called emission factor and change that over time. But to save space, to make it less messy, to have fewer variables, I'm going to calculate this as the total waste burned and then multiplied by the emission factor. So let me quickly open up another version of Leap to get my emission factor to show you how this works. So let me open up a recent Leap dataset. If I go to the non-energy sector and waste incineration, I have emissions of open burning of waste. I have emission factors here in kilogram per ton of waste, so exactly the right format for my for the open burning emissions that I've calculated. So sulfur dioxide emissions 0.5. So I can put 0.5 there. And I'm going to put a question mark A. So I hadn't specified where this total waste burned was, and it's under the landfill branch. So now I'm going to copy this down. So I have this value using the Control D function. I have this equation in each of my for each of my pollutants. All I need to do is change the 0.5 to match the emission factors here. So I have 4.9. I have 38. I have 22.6 for VOCs, 22.6. I have 1.12 for ammonia and 11.9 for PM10. And then I can complete this for all of my pollutants, for both landfill and for uncontrolled. Once I've done that, I have all my values entered. I can simply copy this dataset and paste it underneath municipal solid waste. And this gives me another set of equations that I can call rest of Cambodia. And now all I need to do is change this. So the waste generation rate is different. I've calculated in this spreadsheet a waste generation rate for every province in Cambodia except for Phnom Penh. And it's 55 kilograms per person, 0.55 kilograms per person per year. You can change that to 0.55. Total waste generated is the population times 0.82 to get the total amount of waste that is generated. Fraction combustible, I don't have any information to break it down between Phnom Penh and other areas. Fraction of waste disposed, the same equations. The fraction recycled, the same equations. Fraction burned, I only have the IPCC 2006 default. So the total amount of waste burned is calculated in the same way, and then I have my emissions of different pollutants. I just need to update the emission factors so that they are correct. So I think that is the way in which we can estimate the emissions from municipal solid waste burning. I now want to ask whether my colleagues, whether Eleni or anybody else, you have any points that I've missed in terms of talking about creating the LEAP dataset for municipal solid waste burning, or whether there are any specific questions for our colleagues in Cambodia to consider.
I think you have. I think you've added everything. The only question that I would have is whether the percentages of waste per category are correct, and if that can be double checked, then this is all I have to highlight for now.
Yes, I think that's a very good point. Whether the amount of waste that is metal and glass that has been highlighted in Dr. Sothia's report, whether that is correct, whether the fraction of waste that is disposed in landfill and uncollected waste is correct, and the fraction of waste recycled is correct. You will notice that LEAP is calculating all the values between 2010 and 2017. That is because we set up our historical period for 2010 to 2017. But the data that we've entered was only for 2015, I think Jessica said. So if you have additional data for other years, that would also be really useful to allow us to develop the analysis further. Before we end this video, I want to ask you, I want to look at one final sector, which is medical waste incineration. So thankfully, this is slightly easier. My colleague Ryan has extracted the information from the medical waste the amount of medical waste that is incinerated. It's much lower than municipal solid waste, so it will be a much smaller source. We can capture this by adding a second branch called medical waste incineration. And then we want to, well, actually, I've made a mistake again. We don't need to have medical waste incineration added like that. It's easier and better to insert that branch from another area. So let's take Dr. Sothia's dataset as an example. We don't want to import any of these tags or anything like this. We just want to import the structure of the data. So I'm going to click waste, and I'm going to go back to my urban solid waste burning dataset. And the reason for this is that it gives me all the pollutants. So I don't need to worry about adding these pollutants in. I can simply rename this branch medical waste in incineration. I need to then add in only one user variable, medical waste incinerated. Tons. This is the mass of medical waste incinerated in each year. And then the visibility, this is a non-energy sector category. It's one of these yellow branches because we want to have it visible here. I want it to be visible only for medical waste incineration. It's not a relevant branch for municipal solid waste. So I want it to be visible at this branch, medical waste incineration, and no branches below it. So now I can enter the value, and it was 3,347 tons in 2015. So let me add in interp 2015 3,447. If we have additional data, additional information available, then we can add in the amount of waste incinerated in 2016 or 2017 or 2012 if we have that data. Then what we have to do is enter in our equation for how we're going to use that variable to calculate our emissions. So I'm going to enter in the equation medical waste incineration. This is the folder, the branch. Then I want the variable medical waste incinerated, and then multiplied by an emission factor for SO2, which Ryan has helpfully included here, 0.54 kilogram per ton. Am I right on the units of these emission factors, Ryan? That is 0.54 kilogram per ton of waste incinerated.
That's correct.
Now I've forgotten the number, 0.54. So then we can press Ctrl D to get this equation for each of our pollutants. And then we just need to add in the emission factor. So for NOx, it's 2.3, for CO, 0.19. So let's put in 2.3 and 0.19. And we can continue that for all of the pollutants. This gives us a complete characterization of the waste sector air pollutant emissions for the Cambodia waste model. And what is really nice for the waste model is that it's already linked to a projection. So as our population increases, the amount of waste will also increase. But as people get richer, the amount of waste generated also tends to increase as well. So we have the key variables here needed to create projections and to look at mitigation measures as well. So thank you very much for watching. Please let us know if you have any questions or if there is anything that we can do to help with the waste sector modelling.